Hey guys, today you are doing a stoichiometry checkup. It is just going to be a review of pretty much everything we've done so far in this unit, just with the added benefit of using that stoichiometry map. Now, I'm going to show you how to use the map in an example problem here. Make sure you're paying attention. You definitely don't want to skip this video, and then you will do the other problems on your own. This particular assignment is worth a little bit more. It is worth a prepare grade, so think of like the equivalent of your notebook check. And if you do the first 2 attempts and you're still just not getting it, you need some help, definitely want to come see me in office hours and we can work through them. Okay, so I'm just going to do the first problem for you and then you guys just have 4 to do on your own. So let's go ahead and jump in. So I'm going to do question 1 and I'm going to show you the process, and again it's just going to be a step-by-step taking you through. So it says in this reaction, nitrogen plus hydrogen will yield 2 ammonia. How many grams of hydrogen are needed to produce exactly 1 mole of ammonia? Anytime we're doing a stoichiometry problem, the first thing I want to make note of is what am I starting with and what am I supposed to end up with? Okay, now in this case, it asks how many grams of hydrogen are needed. So that's hydrogen gas because it's H2. But I know my final answer should be in grams of hydrogen. So that is the last thing I'm looking for, is going to be a gram of hydrogen. So I'm looking for a unit of grams. And what I'm starting with is 1 mole of ammonia, and ammonia is NH3. So I know I'm starting with a mole of ammonia, and I know I am ending with grams of hydrogen. Okay, so I'm starting with a mole of ammonia, and I'm ending with grams of hydrogen. So what I'm going to do is come to my map, and I'm going to take a look at my map and see what conversions I have to do. Okay, we start on the left and we go towards the right. So it's just like reading like chemical equations. We start on the left, we go to the right. Now this first problem is actually not a full stoichiometry problem, and what I mean by a full problem, to me a full problem goes from one of the boxes on the left to one of the boxes on the right, but here we're starting with moles. Okay, we're starting with moles of ammonia. So we're starting here at the blue circle, the moles of ammonia, the moles of given. So I'm going to follow my map to where I want to end up. So remember, our problem told us we were starting with moles, we're ending with grams, okay? So I'm going to start with my moles of my given. I'm going to convert to my moles of my unknown, and then I'm going to convert to my grams, okay? It shows me the path that I need to take, and each arrow, because I'm so nice and have given you a full map, each arrow shows you the exact conversion factor that you need to use, okay? So if you can read the map and you can keep all of your numbers straight, it's just plugging in the numbers, okay? So in this instance, we're going from moles to grams, okay? So we have to do it one step at a time, so let's do the first step. So I have to go from moles of my given to my moles of my unknown. So I have to go from moles of ammonia to moles of hydrogen, because that is what we're looking for. We're looking for the grams of hydrogen, so I know I'm going to go to the moles of hydrogen. So what we have to do is make sure our coefficients are balanced, and we have to use our mole ratios here. Okay, this is why we did a whole day of mole ratios. We have to get our mole ratio. So that is the first thing I'm going to do. So I'm going to look at my ratios from my equation, and here I can see there is a 2 in front of, or I have started with 1 mole of ammonia. Let's start there. Let's start with what we know we have. We have 1 mole of NH3. Okay, now I'm going to get my mole ratio. So remember, when we're doing conversions, the thing that we want to eliminate is always on the bottom, right? So I need to take a look and see what is the coefficient that is in front of my ammonia, because I know that my moles of ammonia need to be on the bottom. So my coefficient in front of my ammonia is 2. So I know there's 2 moles of ammonia, and we are converting to hydrogen. So I'm going to take a look at my hydrogen, and there is 3. So for every 3 moles of hydrogen, there are 2 moles of ammonia. So I'm going to put 3 moles of hydrogen on the top. All right, so now we can see that our moles of ammonia are going to eliminate and we're going to be left with moles of hydrogen gas. We have done that first conversion. We've gone from our moles of our given to our moles of our unknown. Okay, now we have to convert to our grams, right? That is the next step because we're going from our moles of our hydrogen now to our grams of hydrogen because in the problem, that's what it wants. So if we take a look at our map, we're going to have to use our molar mass conversion to grams, right? So we have to take our molar mass of our hydrogen and we have to convert to grams. So let's go ahead and do that. Again, this is why we spent a whole day learning about molar mass and doing gram conversions, okay? So I'm going to go back. Oh, new equation. Just going to get my fraction. All right, now, at this point we have converted to the moles of hydrogen, but we want to eliminate those. So I'm going to put 1 mole of hydrogen on the bottom to help eliminate. And I know that my grams of hydrogen are going to go on top, okay? Because that is how we do our conversions. Remember, everything we want to get rid of, the units we're getting rid of, they need to be opposite of each other so that we can eliminate them. So now we have to go to our periodic table. All right, we got to find our hydrogen. It's 1.008. We can round that to 1, but there are 2 of them, right? There are 2 atoms of hydrogen in hydrogen gas because it's H2. So, of course, our molar mass is going to just be 2. Okay, so it's going to be 2 grams of H2 because that is the molar mass. All right, now we are in a position where we can do our calculations, okay, because we've already done all of our conversions. Now we just have to plug it into the calculator. So what I like to do is just make my fraction without any of the units, just so it's easier for me to visualize it when I'm going to punch it into calculator. So on top we'll have that 1 mole of the ammonia times the 3 moles of the H2 times the 2 grams of the H2. So our top is going to be 1 times 3 times 2 divided by the 2 moles of the NH3 and the 1 mole of the H2. Okay, so that would be 1 times 3 times 2 is just 6 divided by 2 is going to give us 3 grams of H2. Right, so the answer is 3 grams of hydrogen gas. Right, now let's go back to our quiz, and 3 grams is an answer, so I'm willing to bet we did that correctly. So here's the thing with these problems. Again, it is just going to be very imperative that you pay attention and you don't get lost. Don't get lost in the map, right? Do it one step at a time. Make sure you have your conversions set up correctly, and then save your math for the end. You could do the math as you go along. I mean, if that's something that you are able to visualize a little bit better, that is something you can do. But for me personally, I like to just go ahead and set it up and then solve. Okay, so again, this map you are using, you just find where you start. So the problem will always give you your starting point. Then you will just hop along the map until you find out where you're going, right? So just use the map as your road map, so to speak. And then remember, each of the arrows are going to be your conversion factor. Like I said, you guys will do the other 4 problems on your own using the map. If you do the first and second attempts and are still you can't figure it out, or you just need some additional help, plan on coming to office hours and we can walk through the problems together. Okay? Hope this helps, and I will catch you guys in class.